Hi everyone, my name's Tobias. It's a great pleasure to be here today. It's my first ever GodotCon. Although I have to admit it's frankly a bit weird being here. It's weird because I'm not a game developer. I'm not an artist, definitely not an artist. Not a game designer, not a sound designer or anything. I'm actually a teacher. Well, more specifically, I'm a lecturer. But to me, that's just a posh word of saying that I teach at university. So now, when you think of me as a lecturer, you probably have images in mind like this one here. One man standing in an auditorium full of young adults eager to learn. Or me like this one here. All eyes on the center of attention, the center of the learning, myself. Or sometimes maybe a bit more realistic. You might think of me standing in the front, looking at empty desks, empty chairs, where my students are supposed to sit. So yeah, I consider myself not only a lecturer, but actually also a teacher. Also a researcher. I research education, so basically I research my own work. And I often ask myself, what do we expect from higher education? Is what I've just shown you education? I'd like to start with some theory, but bear with me, there's going to be a link to games coming very shortly. Here in Europe, our higher education is heavily influenced or guided by the so-called Bologna reform from 1999. The members of the European Union, they agreed on certain standards and guidelines that universities should follow. One of their hopes was that degrees should be standardized and that, for example, accreditation, mobility between universities, especially also between different countries, would be simplified. And one core aspect of the Bologna reform is the focus on learning outcomes and competence-based education. Some fancy words there, sounds very euphemistic, but what does it mean? Well, according to the German education psychologist Rolf Weinert, competence can be defined as competence refers to the cognitive abilities and skills available to individuals or that can be learned by them, enabling them to solve specific problems as well as the associated motivational, volitional and social readiness to use these solutions successfully and responsibly in various situations. I hope you're taking notes. To simplify, let's ask Google instead. So Google says, or actually the American Heritage Dictionary says, competence is the ability to do something well or efficiently. So basically, we want in Europe, and probably in many other countries as well, we want our students to be able to do something, which is great. So that sounds like a fantastic goal to start off from. And one competence that probably many or most, or if not all of you share in this room is the ability to develop games in Godot. So let me ask you the following question. How did you learn how to Godot? Pardon? Despite me being just a lecturer, I actually also have some experience with Godot. And when I first got my hands wet with the engine, I had a look at video tutorials, of course. There's such a long list of videos on YouTube alone that you can watch to learn Godot. There are fantastic resources, endless material. And of course, I also had a look at the documentation. I have to admit, I'm a documentation kind of guy. I read the documentation from start to finish before I write my first line of code. Again, it's a great resource. And then my next step, after having watched hours and hours of videos and after having read through the entire documentation, I felt ready. I booted up Godot, I saw this very window, and I was like, what now? Well, I quickly realized that despite having listened to other developers talk about the subject and about how to do it, I by far wasn't ready enough to code the 3D MMORPG I always dreamed of. I very quickly realized I wasn't competent yet. Because competence does not come just from merely listening to other people talk about the subject, but competence is not just knowing about theory, it's also about practice, of course. A lot of practice in many cases, just like with Godot. So my question is, why is most of our higher education designed around listening to lecturers talk about their favorite subject. Why are lecture halls almost always, just like I've shown you, designed like a cinema, where the lecturer, the only person who's competent in the room, in the field, is the center of the learning process? Well, because practice is not very easily realized. Let's assume we want to teach Godot to our students at university. We could consider that we allow our students to create a 3D open world procedurally generated 4K MMORPG, which surely gives them lots of experience and practice, and probably will be a lot of fun, but we don't have the time for that. Very often we only have 90 minutes to teach a topic with much depth to our students. So, on the other hand, we could just let them create Pong. This could be realized within the time limits, but frankly, it's maybe not be a lot of fun to many students. So, what option should we choose? Well, we can't go with option A, because just like I've told you, we don't have the time for that. That's just an unfortunate truth. But does that mean we have to go with option B, bite the bullet and create Pong? By the way, sorry if anyone's here a Pong lover. I don't mean to hate on Pong. I hope you understand it's just a metaphor. Anyway, I say we sit down and we consider a third option. Activities that are fun, that can be easily done in 90 minutes, and which offer great practice. So I ask myself, what's fun? Well, I know games are fun, of course. Games are fun for so many different reasons. Games, they can feel meaningful, they can feel rewarding, they feel engaging, and for whatever reason they can get us hyped about almost everything. Take Stardew Valley, for example. In real life, I could never become a farmer, yet I could tend hours and hours to my virtual crops. And so with all that being said, I'd like to come to the main topic of my presentation, which is integrating games into the curriculum of higher education. Of course, we can't just let our students play Stardew Valley during class. We still have learning goals to achieve. But the idea is that we build new games, so-called serious games. Serious games are, simply put, games or game elements that are used in a non-entertainment context. So, like learning, for example. Games, on the one hand, they are fun. Learning, on the other hand, can sometimes be exhausting. Games can feel rewarding, like I said, and learning does not always feel like that. So, serious games try to combine both of those worlds. We want games that are fun, but also educational. So let's dive deeper a bit more into practical examples. What I've omitted earlier is that I teach computer science at university, more specifically computer architectures. In simple terms, this means that my students should learn about computer hardware components of modern computers and how these work in detail. And on this slide, I've just listed a few buzzwords just to give you a broad overview. And one of these topics is the CPU instruction pipeline. To very briefly illustrate it, just to give you an example, a computer executes instructions. You could think of it like line by line of your code, just on a machine instruction level. And computers could do this instruction after instruction, but that's very inefficient. And so computer architects, they thought of a pipeline. Because an instruction needs to be fetched from the memory, it needs to be decoded and understood by the processor, it needs to fetch its data, it needs to be executed, it needs to write back its result, and so on and so forth. This is what we call the instruction cycle. So the idea behind the instruction pipeline is that while one instruction is being executed, we can already decode another one, and we fetch a third one. This leads to parallelism, which boosts the performance. Okay. And when I teach this to my students, I always tell them, this is basically like Factorio. Because I know many of them love Factorio, and love is probably still an understatement. In Factorio, you build production chains. You mine ore, you smelt it, and you craft it into higher tier products. And here we have the same principle. We don't wait until the production chain is fully completed until we start mining the next ore. Instead, while we smelt one, we already mine the next one. And so this got me thinking, why don't I just let my students play the instruction cycle? Before I show you what we've built, let me tell you about the biggest enemy we had to face when we originally decided to build simulators at our university and then came to games, and that is Java. Java is said to be a portable language, but the portability basically ends as soon as you start drawing something on a canvas, because then you need a very specific SDK version. It only works on the machine where you exported it from, so no Mac if you programmed it on a Linux. And since our classes work with the bring your own device principle, we have Linux people, Mac people, Windows people, we have people with tablets. So we chose Java because we thought it's portable, but it actually wasn't. And you know what else is horrible? Coding UI in Java. Because boy, it's unfun to lay out something in code. So I think the solution to all our problems is very obvious to all of you. It wasn't obvious to me back then. Because we needed a framework that was easy to use, easy to learn, portable, free to use, because we're programming non-commercial products. And it needs to be excellent when creating UIs. And so here I am at GodotCon telling all of you the most obvious thing, but the thing that enriched our lives by a lot, which is we switched to Godot. And, well, life is great right now. Because Godot offers exactly what we needed, super beginner-friendly, which means that I can have student assistants work on MVPs of new simulators and games in less than 2 months. It's free to use, open source, super important in public education. It's portable, we can even export it for the web, so that eradicates the need to even download the simulator in class. And yeah, it's just really fun to use. So here's the first project we realized fully in Godot. I'd like to repeat, I'm not an artist. This is the instruction pipeline game we worked on. So basically, you build a CPU pipeline with an increasing level of difficulty. You start with simple hardware components that you put into a production chain-like arrangement, and then you test it in regards to performance and hardware costs, try to optimize it with a sample program. There's a level tree, you then get deeper, you learn about topics like superscalarity, data hazards, optimizations, and so on and so forth. And the great thing is, you learn all that while playing. Another game we've built by now is a GPU simulator, because learning GPU programming, graphics card programming is super difficult, even if you're familiar with normal CPU-based programming, because the style is just very different. There's a different concept lying behind that. And so even for skilled programmers, it feels like learning a new language all over again. And so what we've done is we built like a block-based program where you write GPU programs essentially like in Scratch. But for Godot, there's no need to worry about syntax or what operations are supported. You just focus on learning the concepts behind it. And thanks to yet another gamified level design and an instant feedback loop, the students are guided through their individual learning process. The new simulation game we're currently working on, again, not an artist, is about so-called Tomasulo algorithm, which many modern CPUs use. That's still a work in progress. We are working on microprogramming, main memory simulators, and so on and so forth. Okay, many in the pipeline. So, I initially told you that I'm not only a lecturer, but also a researcher. So you might wonder right now, I've sold you serious games as the perfect solution to everything so far. So where's the research exactly? Well, to put it very simply, I think we can all agree that games are fun, at least to most people. But the important question is, can they also serve as an efficient and effective learning? Luckily, I'm not the only one who thinks about this question day and night. There's loads of research in the field. It's a fast-growing field as well. I could list inside from thousands of scientific publications on gamification and game-based learning. There's more, but I don't think we have the time to go over all of them. So instead, I'll just summarize one major discussion that's going on in that scene in the past couple of years. And that is, many researchers have found that using game-based learning increases the learner's motivation. And also often it has positive impacts on the learner's performance, which is great. But some others claim and have found that it can also decrease your motivation. And that's not because the game is not fun or anything, or because it's too challenging. But actually the problem might be that gamification can also replace an intrinsic motivation by an extrinsic motivation. This means you might feel motivated towards a subject initially just because you find it interesting, but then because you spend time playing a game which rewards you with stars, achievements and high ranks on a leaderboard, you suddenly start to strive for an external motivation instead. You no longer study the subject because you're interested in the topic, but because you get addicted to the positive feedback the game gives you. In the end, the discussion is not black or white, just like game-based learning is not black or white. There are many different aspects to gamification, many different elements, like as you can see here, leaderboards, achievements, customization, storytelling, and so on and so forth. And so my personal research interest lies in studying these different elements in computer science education, so the combination of both. I've started working on that about 3 years ago, so I'm still rather at the beginning, I'd say. I've got some experience, but not a conclusive answer yet. So I'm still excited to find out what lies ahead of me. What else is in the future? Well, one big project of mine currently is to build a platform in Godot that combines all the topics, all the simulators we're working on into one big serious game. A game that will essentially guide you through an entire semester of computer architectures that will teach you about from the CPU instruction cycle to caches, to main memory, to GPUs and so on and so forth. So this is basically my open world MMORPG I currently dream of. And thanks to Godot, the Godot staff, the Godot community especially, this dream of mine has transitioned from being just a dream to being an actual plan. And so this presentation of mine also, to me, serves a way to express gratitude. Well, and with my presentation now coming to an end, I hope to have inspired perhaps some of you to also build a serious game in the future, because I strongly believe education matters, and especially we need to rethink the way we teach. Thank you very much.
We now have some time for some questions, if there are some.
Thank you for the talk, very interesting. I was wondering, for the games that you created yourself, what were the outcomes that you have observed? Was it about motivation? Was it about efficiency? Or are you still checking that out?
We're not always just asking or want to find out, is it motivating? This is something we do measure, it was motivating, but when we try and test these in my specific setup, we research in more specific areas. Like for example, in the game that I've showed you, the pipeline simulator, we did not test, is this game motivating or anything? But actually we had A/B testing, we tried different game elements. One part of the class, they worked with a simulator that did include quizzes between levels. The other class, they had just the normal build your CPU levels with no quizzes in between. And so we tested, is this quiz-based game element efficient or not? And there the effects were basically that it slightly boosted the motivation once more when you feel like, oh, I actually have to know what I'm doing here. I'm being tested in a second. But yeah, it was not like this is the thing to go on from now on. Yeah.
Thank you for the talk. I'm very interested in building these types of simulations with Godot. Is there anything that you feel like you learned in building several of these that you wish you knew at the start, or either about the UX or the architecture or the programming patterns, etc.?
The thing is that I've showed you screenshots of very different simulators, and I think there's even more that I did not put on the slides. And they were not all built by myself alone. I work on these together with student assistants. And so every simulator was built by someone else. And this is exactly then a problem that I observed, is that every one of them had to reinvent the wheel essentially. And this is exactly why I am now planning on building one big platform for the simulators, where I have things that I noticed that I always need. For example, all of these simulators, they always gave you feedback via pop-ups, or they gave you star rankings depending on how well you did. There's something that needed to be reinvented in every single simulator. And so I work on building this one platform that I can then reuse and recycle for every single game essentially.
So coming back on the last question, did you test the long-term knowledge difference between the two groups?
The pipeline simulator that was tested 3 months ago, so the results are still preliminary. My students took an exam 2 weeks ago, so I'm excited to find out. I don't know yet in that case.
That was exactly my question.
All right, lovely.
Yeah, thank you. Slightly similar, but still different. Aren't you afraid that they now learn something within the context of the game, so that how does it transfer to applying it to completely different situations, like in a real life context?
Yes.
So when it's not a scratch thing anymore, but they should actually do something in the real world, so to say.
Exactly, and I think here actually lies the strength of all this, because we have to compare to how we taught these subjects beforehand. Usually, the way we teach them is paper-based. We give them a very abstract, very far away from real-life task, like calculate based on this formula the outcome, fill out this table or something within a limited amount of time. And so we know that education in many cases is already very far away from real life. And the reason for this is because we do paper-based education so far most of the time. And so now that we can use simulators, we get a bit closer. I don't just ask theoretical formulas for pipelines, the speed-up formula, whatever. Instead, I can have them build and design their own CPUs to some abstract extent, of course. But my hope is that then they go one step further. They don't just follow the formula that I gave them, but instead they can try out their own ideas and concepts, see what works, get feedback from the tool, and then get more competent.
How strictly would you consider them games? Because to me they remind me of like the interactive explorations of like Brett Victor, for example, and these kind of things. They're interactive mediums, but they're not really about a goal like a game normally has, for example.
Yes, it depends on the simulator we build. We have some simulators that I would consider not games because they are just that, simulators. But for example, the one I've showed you with the pipeline, this one has different game-like elements. For example, it has levels that you go through, which is unusual for a simulator. Normally, simulators are more sandbox-like. What you can't see here, I think that was not in that version. Every level has a star ranking system on how well you did, like from 1 star to 3 stars, which should also be displayed here. So you get some rewards for performing well. There's also a bit of storytelling going on there. When you start a level, it will tell you a bit of a background story, like you are designing now for this company, etc., and this is your task. Of course, I think this would not be a bestseller on Steam, but it tries to include some of the game-like elements to still be a simulator, a serious simulator in education, but also with engaging game-like elements included in them. So basically, we take some from these, put it into our simulator, and call it a serious game.
Last question.
I had a question regarding age groups, and so I'm assuming you're doing it with young adults, but how does gamification and especially these kind of applications can be used for other groups like teenagers or children? Is that does that work with those age groups, or is it not recommended and we have other ways of teaching them what they need to know, I guess?
I'm more of an expert in higher education, so 18 plus, essentially, students at university. though I am quite confident in saying that it works especially well with teenagers or younger kids. Though I would go as far as to say everyone likes playing, not only kids, but also adults. And that's what I'm trying to show in a higher education setting, is that even though we are training to work on at a serious job one day, we do like playing still. We do like getting rewarded. We do like having we do like immersing ourselves in a story. And it works at university, and I think it works just as well, if not better, at schools as well. All right. Well, thank you very much.